Okay students, we have done up to question number 5 in the previous video. Now question number 6 of exercise 9.4 is, for the broad term of the question remains the same, that find the sum to n terms of the series, and the series in the sixth question is given as 3 into 8 plus 6 into 11 plus 9 into 14 and so on till n comes. Now let's go for the solution part. Here, if we see the pattern here, that the first terms of the first term of the each term, that means 3, 6, 9 are forming a pattern of a 3n as discussed in previous questions also, into, now if I look at the part of 8, 11, 14, so these all form a AP. So if for that, if you go into the rough column and see carefully that 8, 11, 14 and so on, it forms a part of an AP. And for the nth term, I can use the formula of an, which is a plus n minus 1d. So here a is 8, n is n, and d is 11 minus 8, 3. So it would be 8 plus 3n minus 3. So it would be 3n plus 5. So the second part of each term is 3n plus 5. So this is also a way to get the nth term an for these series type questions. So the first part is 3n, which is clearly visible as 3 into 1, 3 into 2, 3 into 3, and the second part, which is 8, 11, 14, it is forming a AP this time, so we can use the formula of nth term for an AP, and by that we have got the second part as 3n plus 5. So this is our an. Now an would be 9n square plus 15n. As discussed, the sum of series is given by Sn and it is summation of an. So it would be summation of 9n square plus 15n. So which will be 9 summation of n square plus 15 summation of n. We have discussed in the last video that the constant comes out of the summation, only the variable part remains in the question. Fine. Now we have discussed the formula of summation n square and summation n cube and summation 1 in the last video. You can refer that for the formulas list. Now summation of n square will be n into n plus 1 into 2n plus 1 whole divided by 6 plus 15 times of summation n is n into n plus 1 by 2. So it would be 3 3s are 9, 3 2s are 6. So we can take now 3n into n plus 1 by 2 as common part, and we will be left with 2n plus 1 plus 5. So which would be, so this will equal to 3n into n plus 1 by 2, and it would be 2n. It was 2n plus 1 plus 5, so it would be 2n plus 6. Now I can take 2 common, so it would be 3n into n plus 1 by 2 into 2 is taken common out, so it would be n plus 3. 2 and 2 cancel out, so the final answer is 3n into n plus 1 into n plus 3. So this is our answer. I hope the question is simple and it is very clear to you. Now comes to the question number 7. The question says, find the sum of the series, and the series is, first term is 1 square, the second term is 1 square plus 2 square, and third term is 1 square plus 2 square plus 3 square, and so on till n terms. Now here also the pattern is clearly visible. The first term is 1 square, second term is 1 square plus 2 square, third term is 1 square plus 2 square plus 3 square, and the fourth term would be 1 square plus 2 square plus 3 square plus 4 square, and in the same way the nth term would be given by an is equal to 1 square plus 2 square plus 3 square and so on up to n square. Okay. We know that it is denoted by summation n square. So this is a very special question in which an is in terms of summation. जो एन आ रहा है वो भी समेशन के टर्म्स में आ रहा है, एंड वी नो दैट समेशन ऑफ एन स्क्वायर इज गिवन बाय एन इंटू एन प्लस वन इंटू टू एन प्लस वन होल डिवाइड बाय सिक्स. सो let's just simplify the an first. So an is n into n plus 1 would be equal to n square plus n, and this 2n plus 1 by 6 will remain as it is. Now multiply the bracket, so it will become 2n cube plus n square plus 2n square plus n whole divided by 6. So an will be equal to 2n cube by 6 plus, I am separating the each term with the denominator, 3n square by 6 plus n by 6. So therefore finally an is n cube by 3 plus n square by 2 and plus n by 6. So now Sn will be equal to summation of an, so it will be equal to summation of n cube by 3 plus n square by 2 plus n by 6, which will be equal to 1 by 3 summation of n cube plus 1 by 2 summation of n square plus 1 by 6 summation of n. Now this will be equal to 1 by 3. Substitute the value of n cube, summation of n cube, which is n square into n plus 1 whole square by 4 plus half. Summation of n square is n into n plus 1 into 2n plus 1 by 6, and summation of n is n 1 by 6 n plus 1 by 2. So we can clearly say that denominator is 12 in each term, and we can take n into n plus 1 by 12 common from each term. So now this will be left with n into n plus 1, this will be left with 2n plus 1, and the last term will be left with 1 only. So here it is n into n plus 1 by 12 into n square plus n plus 2n plus 2. So finally Sn would be n into n plus 1 into n square plus 3n plus 2 whole divided by 12. Now we can factorize this quadratic term as well. So I am directly factorizing it, but I am using the concept of multiple splitting, but I am directly factorizing here. So the factors would be n plus 1 into n plus 2 whole divided by 12. So the final answer is n. Sn is n into n plus 1 whole square into n plus 2 whole divided by 12. So this is our final answer for this question. Fine. Now if I come to question number 8, the question number 8 is different from these 7 questions, as we don't need to find the an here. The an is already given in the question. So this is a different question, but as we have to find an for each question till now, question number 8 is find the sum to n terms. The broader question remains the same, that we have to find the sum to n terms, but here an is given. An is given as n into n plus 1 into n plus 4. So our working part is reduced to Sn only. So what will we do? We will first simplify the an. It would be n square plus n into n plus 4, which will further be equal to n cube plus 4n square plus n cube plus 4n n square, this pen is not working properly, n cube plus 4n square plus n square plus 4n. So which will be equal to n cube plus 5n square plus 4n. So we got the an here. Now Sn is given by summation of an, so it will be equal to summation of n cube plus 5n square plus 4n, which will be further equal to summation n cube plus 5 times summation n square plus 4 times summation n. Now substituting the values, we will get n square into n plus 1 whole square divided by 4 plus 5 times of n into n plus 1 by into 2n plus 1 by 6 plus 4 times of n into n plus 1 by 2. Fine. So this 2 and 4 will be cancelled out. Again I can take n into n plus 1 as common. I will be left with n into n plus 1 by 4 plus 5 times of 2n plus 1 by 6 plus 2. So the LCM would be 12 of 4 and 6. So it would be 3n into n plus 1 plus 10 into 2n plus 1 plus 24. Now it will be n into n plus 1 into 3n square plus 3n plus 20n plus 10 plus 24 whole divided by 12. N into n plus 1 will into 3n square. Now it would be 23n plus 24 plus 10 is 34 whole divided by 12. So this is the complete answer. Fine. Now let's go to question number 9. The question number 9 is an is equal to n square plus 2 raised to power n. This is a very interesting question. Let's see the question first. The question is an is this. An is the most in the simplified version. Now let's proceed with the question. Sn would be summation of n square plus 2 raised to power n, which will be summation of n square plus summation of 2 raised to power n. Now look carefully. Summation of n square, we know it is given by n into n plus 1 into 2n plus 1 by 6. Now summation of 2 raised to power n would be 2 raised to power 1 plus 2 raised to power 2 plus 2 raised to power 3 and so on till 2 raised to power n. Let's understand this first. We know n here is a natural number, so the value of n starts from 1 and it will keep increasing by 2, 3, 4 until up to n. And summation means ki substitute the value of n and then add the following terms. So first of all I will put the value of n equal to 1, then I will change the value of n to 2 and add it to the first term. Then I will change the value of n to 3 because the next natural number is 3 after 2. Then it will be added to the series and so on. The series is formed. Now if you look carefully, this becomes GP with first term a as 2 and common ratio r as 2 square upon 2, which is equal to 4 by 2 is equal to 1, and the number of terms are n here. So it would be n into n plus 1 into 2n plus 1 whole divided by 6, and the sum of the GP is given by a r raised to power n minus 1 upon r minus 1. So it would be n into n plus 1 into 2n plus 1 by 6 plus 2 into 2 raised to power n minus 1 upon 2 minus 1. So the final answer is, because there is nothing common to take over here, so we will leave the answer here only. It will be 2 into 2 raised to power n minus 1. So this is our answer for this question. Fine. Let's come to the last question of this exercise, which is question number 10. And for the question number 10, an is given as 2n minus 1 whole square. 2n minus 1 whole square. Now, the solution part is an is equal to 2n minus 1 whole square, which will be equal to 4n square plus 1 minus 4n. I can add it in the proper order as 4n square minus 4n plus 1. Now Sn will be equal to summation of an, which will be equal to summation 4n square minus 4n plus 1, which is equal to 4 times of summation n square minus 4 times of summation n plus summation of 1. Now 4 into summation of n square is n into n plus 1 into 2n plus 1 by 6 minus 4 times of n into n plus 1 by 2, and summation of 1 is n. See, in the class videos, in the class lecture, we have done this, that summation of 1 is equal to n. Now 2 2s are 2 3s are 2 1s are 2 2s are. So it would be 2 into n plus 1 into 2n plus 1 by 3 minus twice of n into n plus 1 plus n. Fine. Now I can take n common, so I will be left with twice of n plus 1 into 2n plus 1 by 3 minus twice of n plus 1 plus 1. Fine. Now if I look carefully, I will get, let's reduce it so that I can see the last term here. Let's reduce it further. The last term is n here. Now if I multiply the bracket, it will be 2n plus 2 into 2n plus 1 upon 3. Then I will open the brackets, minus 2n minus 2 minus 2 plus 1. Now it will be n. If I take the LCM as 3, so it would be 4n square plus 2n plus 4n plus 2. Now if I take the LCM, it would be minus 6n. This minus 2 plus 1 will be minus 1, so it would be minus 3. So now I will be left with n into 4n square plus 6n minus 6n, and 2 minus 3 is minus 1 whole divided by 3. So 6n and 6n is cancelled out, so I'll be left with n into 4n square minus 1 by 3. Now we can use the identity of a square minus b square in 4n square minus 1, so it can be done as n into 2n minus 1 into 2n plus 1 whole divided by 3. So this is the final answer. So this exercise is over. I hope you have liked our video, and if you really like the video, then please share it with your friends and tell them to subscribe the channel. You also subscribe the channel, because I will be giving you the solution of every question of NCERT. Soon the all videos will be uploaded, and press the bell icon so that whenever a new video is uploaded, you can get the information. Take care. God bless you all. Thank you.